Welcome to Day 4 of Open Cloud Platform K-PaaS Specialist Training. Objectives for Day 4 are as follows. After the lecture, trainee will be able to understand the deployment flow and architecture the exercising environment, and be able to build the environment utilizing the virtual machine, Minikube and Podman. Lastly, be able to build MSA applications by creating container images and deploy containers in the configured environment of K-PaaS Container Platform. Table of Contents for Day 4. Section 1. Outline and Understanding the Architecture. Section 2. Installation of the Virtual Machine. Section 3. Installation of Minikube and Podman. And Section 4. MSA Application Deployment. Section 1. Outline and Understanding Architecture. In Section 1, we will learn about the outline and architecture of Container Platform Exercise Environment. Part 1. Outline of Exercises. The goal of the day for exercise is to create a container image and deploy that image to build a microservices architecture application. To accomplish this goal, we will utilize the procedures and tools found in the textbook. The practice exercise consists of 3 main steps. Create an environment, create a container image, and deploy a container image. To break it down, the environment setup consists of creating a virtual machine, building a cluster, and building a container engine. Next, the container image creation step consists of setting up the deployment file, building a DB, creating a WAR file, creating and uploading a container image, and finally deploying the image to build an application. By the end of the exercise, you will have implemented an application with a microservices architecture that includes sign-up, message board, and commenting functionality. Part 2. Understanding Architecture Components. The picture 1 the textbook is the overall architecture configuration of Container Platform Exercise Environment. Let's start with Session, which is located on the right side at the top of the diagram. The session uses Redis to store and manage data. It also works with the UI system to store the session values needed to access the portal. The UI system shown at the center is responsible for servicing the on-screen functionality that works on user interface screens, such as login, sign up, bulletin board, and commenting. The API gateway at the bottom of the UI system is responsible for routing and load balancing data that comes in through the UI system to the front end of the API server, unifying the endpoints for posts, comments, and user API servers. The Posts API system in the left of the diagram is responsible for processing data to process the posts created by the UI system. The Comments API system is responsible for handling data related to comments made by the UI system. The User API system is responsible for handling user-related data, such as sign-ups and logins, in the UI system. Next, the database. The post, comment, and user databases are operated independently by building a database for each service. The database is responsible for storing data related to posts, comments, and users created by the UI system through each API system. It also stores the data in an independent DB, or retrieve related data from each DB and providing data to be displayed on the UI screen. In this part, we will see the deployment flowchart of the exercise environment. First, we install VMware, configure the Ubuntu 20.0 for environment as the operating system, install Minikube, which allows us to use some features of the master node, and install kubectl, a CLI tool to control the cluster. Third, we install Podman, the container engine, by registering a Cubic project repository for Podman installation. That's it for configuring the deployment environment for deploying the architecture. Next, we build the environment to work with each API system by deploying Redis and each database environment first. Then, we build each API as a WAR file and use Podman to create and deploy the image. Finally, we complete the configuration of each API environment by writing YAML files and deploying them to Minikube. This concludes the exercise overview and architecture understanding in Section 1. In Section 2, you will practice installing a virtual machine